Bismillahirrahmanirrahim. I'm Khidr Chughtai and you're watching my YouTube channel Khidr Chughtai School of Advanced Chemistry. I'm going to explain today I'm going to explain my previous lecture once again, that is about stoichiometry and mole ratio. To solve the question from the past paper history, especially for P2 questions, you should know different formulas. For example, the percentage purity, mass percentage, formulas regarding moles, formulas regarding concentration, and so on. You must know how to make empirical formula. What are the basic method of calculation that is said to be unitary method, and so on. Unitary method, concentrations, formulas to calculate empirical formula, or steps to calculate the empirical formula, and formula to find the concentration, that is as a result of acid-base reaction. So these are the typical 1, 2, 3, 4, 5, and 6, 7. Overall, I think 6 to 7 formulae are over here. Those are used to solve all type of question present in your P2 O-level chemistry. Let's talk about it. I'm going to explain this question, that is question B, part B, May June 18, variant 21 question. Barium chloride can be prepared by reacting barium carbonate with a dilute hydrochloric acid. Excess barium carbonate is reacted with 40 centimeter cube of 1.5 mole per dm cube HCl. After purification of the percentage yield of the barium chloride was 75.0%. Calculate the mass of barium chloride prepared. Give your answer up to the 3 significant figures, and the barium chloride has Mr2O8. Okay, so in this case, basically, two formulas are applicable in this question. Number one, the unitary method, because you know here is a chemical equation, there is a balanced chemical equation. And the second one formula is the percentage yield. As he is letting us know, the percentage yield is 75.0%. The next thing that you should focus on it is this one. In this case, you know, this volume and mole per dm cube. What is the use of these quantities? Basically, volume and mole per dm cube of a substance gives us the moles. So we can, calculate the mole whenever you are going to multiply this volume into mole per dm cube. So first of all, I'm going to find the mole of this barium carbonate. What is the mole of barium carbonate? Mole of BaCO3, and it is equal to 40 into 1.5 divided by 1000, because this volume is in centimeter cube. So I will divide 1000 divided by 1000. And the answer is, let me check it from my calculator, 40 into 1.5, that is equal to 60, and divided by is 1000, and here is 0.06 if I am not wrong. So 0.06 moles of barium carbonate is over here. Now he is saying after purification the percentage yield of the barium chloride is 75%. At the moment, you can say that barium chloride percentage is given. So I am going to apply percentage yield formula. What is the formula that is said to be the percentage yield? What is the formula that is said to be the percentage yield? That formula is percentage yield, that is equal to experimental yield divided by calculated yield into 100. Now we are having the answer of this percentage yield, right? We are having the moles of this barium carbonate, the moles of HCl, not barium carbonate, I'm sorry for that. Moles of HCl, these are moles of HCl. Mole of HCl, those are going to react with the moles of the barium carbonate. And you are going to find the mass of the barium chloride, and here the percentage is given. Okay, now we can find the calculated answer. We can find this answer, that is the calculated answer, you can say. Now, with respect to this mole of HCl, with respect to the mole of these HCl, I am going to find the mole of barium chloride that can be made. According to this chemical equation, you can say that I am going to find the mole of BaCl2 with respect to HCl. So, according to this balanced chemical equation, what is the MR or the mole? You can say, you can use mole, you can use MR, both quantities can be used. Mole of HCl is equal to 2. If you are using mole over here, yes, you can use it. And the mass of barium chloride. What is the mass of this barium chloride? Please let me know in the comment section. What is the mass of barium chloride? Yes. What is the mass of BaCl2? Ba plus Cl2. Cl2 is equal to 71. What is the MR of barium? Let me check it over here. The AR of the barium is equal to 137.3. So 137.3 or 137 you can say plus 71. 137 plus 71. 137 plus 71, that is equal to 208, and oh, it's given already. 208. So according to the balanced chemical equation, 2 moles of HCl is going to make 208 gram of BaCl2. It's a given, you can say. It's a given, data. According to this balanced chemical equation, 2 mole of HCl are going to yield 208 gram of barium chloride. What about 1 mole? It will be equal to 208 divided by 2 moles. It will be equal to 104 gram. And at the moment, we are using 0.06 moles. If we are using 0.06 moles, how much barium chloride should be formed? The maximum quantity that should be made, that is this one. If you are using this one, then simply 104 multiply by 0.06. 104 multiplied by 0.06, and the answer is 6.24 if I'm not wrong. 6.24. This is the calculated answer. 6.24. So maximum answer of the barium chloride that can be made is 6.24. The percentage yield is 75%. Experimental yield he is asking to find, and let's suppose it is equal to X. 6.24 in 200. So what will be the answer of the X? This X will be equal to 75 into 6.24 divided by 100 if I'm not wrong. 6.24 multiplied by 75 and divided by 100, and here is the answer. 4.68 gram is the experimental value of the barium chloride that can be made in this experiment. So that was the 3-mark question. You will find the mole of HCl first of all, then you will find this answer 6.24, and the final answer. These are the basic, you can say, divisions of the marks. 1 mark over here, 1 mark over here, and 1 mark over here. Now I'll come towards the next one. Ethanol is used as a fuel. Ethanol plus oxygen goes to 3 mole of H2O and 2 mole of CO2. The complete combustion of 1 mole of ethanol releases 1350 kilojoule of energy. So once again, the data is given. The data is equal to 1 mole of ethanol, C2H5OH, is going to burn 1350 kilojoules energy. A sample of ethanol react with excess oxygen to make 0.240 dm cube carbon dioxide at room temperature and pressure. Find the or calculate the energy released in kilojoules in this reaction. Now the number one given data is over here, this one. Whenever you are going to burn 1 mole of ethanol, 1350 kilojoule energy is formed. Now in this experiment, how much moles are you going to burn? So I am going to find the number of mole with respect to CO2. I am going to find the number of mole of ethanol with respect to this carbon dioxide, with respect to this CO2. Now, first of all, I am going to find the mole of CO2. You know that 0.24 dm cube divided by 24, that is equal to the answer of mole. I mean, you know, 1 mole or you can say 24 dm cube is equal to 1 mole of a gas at RTP, at room temperature and pressure. Any gas that is having 24 dm cube of volume, it will be equal to its 1 mole. It will be equal to 1 mole, right? Okay, 0.24 divided by 24, that is equal to 0.01. 0.01 mole of CO2. CO2 moles are over here. So according to the balanced chemical equation, from equation you can say that 2 mole of CO2 is equal to 1 mole of C2H5OH, I mean ethanol. 2 mole of CO2 when that is going to be made, at that time 1 mole of ethanol is going to burn. The next one is, if you are making 1 mole of CO2, it will be half mole of C2H5OH, and at the moment the amount of CO2 that is being formed is 0.01. So what will be the answer of required mole of ethanol? It will be half into 0.01 and divided by 2, and it will be 0.005 if I'm not wrong. 0.005, or you can say 5 into 10 to the power minus 3. So this is the answer of the mole of ethanol that is going to burn in this experiment. If 1 mole is burnt, here is the answer. Now you are going to burn this one. What will be the answer? That is very much simple. Once again, a unitary method. 1 mole burning gives 1350 kilojoules, and 5 into 10 raised to the power minus 3 will give us 1350 into 5 into 10 raised to the power minus 3. I mean, multiply by this answer, and you will get 6.75. 6.75 is the answer of energy released in this experiment, right? Right. Okay, come to the next one. Silver nitrate can be prepared by reacting silver oxide with dilute nitric acid. Ag2O plus HNO3 goes to AgNO3 plus H2O. Excess silver oxide is reacted with 30 centimeter cube of 0.150 mole per dm cube of the nitric acid. Once again, you can see that the volume and the mole per dm cube, the concentration gives us moles. So we can find moles of HNO3 from this data. And you know, here is the equation. You can apply unitary method. Once again, there is a percentage purity, the percentage yield is given. You can apply the percentage yield formula as well. So first of all, we can calculate the mole of nitric acid. So it is equal to 30 into 0.150 divided by 1000. So 30 multiplied by 0.150 and divided by 1000, and answer is 1.5 into 10 raised to power minus 3. 1.5 into 10 raised to power minus 3 is the answer. 4.5 if I'm not wrong. 4.5 into 10 raised to power minus 3 is the number of mole of nitric acid. So once again, he is asking to find the mass of silver nitrate that is prepared, we are going to prepare experimentally. The mass of silver nitrate is also given. And with respect to this mole of HNO3, we can find the mass of silver nitrate. That is to be calculated. Once again, I'm going to apply the percentage yield formula. Percentage yield is equal to experimental value divided by calculated value into 100. In this case, once again, he is asking to find the answer of this experimental yield. That can be synthesized in this experiment. Percentage yield is given, its answer is 80%. And this experimental yield is finally to be found. So I'm going to write X over here into 100. And now I am going to find how can we made, or how much amount of this silver nitrate that can be made up to the maximum extent. According to this chemical equation, 2 mole of HNO3 is equal to 2 mole of AgNO3. So AgNO3 that should be made up to the maximum extent, it will be 4.5 into 10 raised to power minus 3. That is the mole that can be made. According to the balanced chemical equation, the mole of HNO3 is equal to the mole of AgNO3. So the quantity of HNO3 used will give the same quantity of, with respect to mole, same mole of AgNO3. Now I'm going to change this mole into the mass. And you know what is the formula is mole is equal to mass over mr, or mass is equal to mole into mr. And mole is equal to 4.5 into 10 raised to power minus 3. mr of this AgNO3 is equal to 170. So 170 into the mole is equal to this one, 0.675 gram. 0.765 grams. So this is the maximum quantity according to our calculation that can be made by this experiment. So I'm going to write it over here, 0.765 gram, and I'm going to find the value of X. So X will be, you can say 80 into 0.765 over 100. Yes. So 0.765 multiplied by 80 and divided by 100. If I'm not wrong, the answer is 0.612 gram. 0.612 gram and so on. If the mass obtained experimentally that is equal to 0.612 gram, then at that time the percentage yield will be 80%. This is the easiest method as far as my knowledge is concerned, my opinion is concerned, my experience is concerned. You can say you can see that you can use this data to find the moles, number one. Then if the percentage is given, then you can apply it directly. This formula, and you can get the required answer and so on. Come toward the next one. Phosphorus is a non-metal in group 5 of the periodic table. Phosphorus can be manufactured from calcium phosphate. Calcium phosphate can react with SiO2 plus 10 carbons, mole of carbons, calcium silicate, 10 mole of CO, and P4, 1 mole of phosphorus is going to form. What is the maximum mass of the phosphorus that can be made by using 300 gram of silicon dioxide? That is a simple question, direct question. And again, you can say a balanced chemical equation is given over here. So I am going to use unitary method. Unitary method is this one. I'm going to write equal over here. What is to be find is on the right hand side, given species are reported on the left hand side, and one information, the first information is taken from the balanced chemical equation. I'm going to find the mass of phosphorus. Grams of the phosphorus, and given is also grams, that is of silicon dioxide. From the balanced chemical equation, calculate the mass of SiO2 with respect to 6 moles. Don't forget to multiply this 6. 6 into the MR of this SiO2. What is the MR of silicon? That is 28. 28 plus 32 for oxygen and it's equal to 60 multiplied by 6, and answer is 360. 360 gram is the answer from the balanced chemical equation. Is the answer of SiO2. So according to the equation, we are using 360 gram, that is SiO2. How much phosphorus is going to be made in this case according to this balanced chemical equation? What is the mass of phosphorus? 4 into SAR, that is equal to 31, if I am not wrong. It's equal to, yes, 31. So its answer is 124. Now you are having the simplest calculation. I mean, you can compare these two values manually, you can say. Once again, 360 gram can be used to make 124 gram. If I am using 1 gram of SiO2, the answer will be 124 over 360. And at the moment we are using 300 gram. At the moment in this experiment we are using 300 gram. So ultimately multiply the whole answer by 300. So what should be the answer? I mean, 124 multiplied by 300 and divided by 360. The answer is 103.33, if I am not wrong. 103.33 gram is the answer. Correct. Good, Kamar. Good, Uzair. Thank you very much. The next one question is, once again, the 2-mark question, the simplest one. Excuse me. Sphalerite is an ore containing compound of zinc. One of the compound in the ore is ZnS. Calculate the mass of zinc in 30 tons of ZnS. Now in this case, only one formula is given, you can say that. Only formula is given, and you are going to find the answer from that formula. Once again, unitary method is applied. Whenever you are going to get information from balanced chemical equation, or you are going to get the information from a formula, you will use unitary method or unitary rule. So let's talk about it. For example, forget about the tons. For example, I'm going to write tin S. What is the MR of this zinc S? The MR of the zinc is equal to 65.4 plus its sulfur is 32, 65.4 plus 32, that is equal to 97.4. So if the formula is given and I am supposed to find the answer from the formula, so I will start from MR. MR is equal to 97. So I am going to compare this ZnS that is given, and what is to find in this question, that is the mass of zinc, only zinc. So if we purchase 97.4 gram from a shopkeeper, that is ZnS, if we purchase 97.4 gram ZnS, at that time how much zinc will be there? Obviously it will be 65.4. I mean, don't forget to convert the units basically, or you can say you can ignore these units. First of all, I'm going to ignore these units initially. 97.4 gram of ZnS grams is equal to how much grams? 65.4 grams. But I can suppose them as in tons. Yes, it is true. If I want to suppose them into the tons, there is no need to convert into the tons. Simply suppose that if the 97.4 tons are over here, that will be equal to 65.4 tons of zinc. Now, if 1 ton is, I'm going to purchase 1 ton, or we are having 1 ton, it will be, its answer will be 65 over 0.4 over 97.4. And at the moment, we are using, finally, in the experiment, in the recent condition, we have taken 30 tons of ZNS. So multiply by 30 to this whole calculation. I mean 65.4 multiply by 30 and divide by 97.4, and the answer is 20.14 tons. There is no need to convert gram into the tons. Good, thank you, Uzair, thank you, Kamar. There is no need to convert tons into grams or grams into the tons, and so on. The next one question is, once again, I think it's from percentage yield. Yes. Titanium is made by reducing titanium chloride using magnesium. TiCl4 plus Mg goes to MgCl2 plus Ti. Calculate the mass of titanium made from 1000 gram of TiCl4. Calculate the mass of titanium made from the 1000 gram. The reaction has 90% percentage yield. Give the answer to the two significant figures. The relative atomic mass of the titanium is 48. So in this case, we are going to find this TiCl4 with respect to percentage yield, and in this case we are going to make 1000 gram of TiCl4, not MgCl2, sorry for that. We are going to calculate the mass of yield that is made from TiCl4. This is the basic reactant. These both are said to be the yield, not only MgCl2, you can say. So what will be the answer if the percentage yield is 90%? Once again, calculate the mass of titanium. Now I am going to write the basic equation or the basic formula that is said to be the unitary method. According to the balanced chemical equation, what is the mass of TiCl4 and what is the MR of Ti? So I am going to make Ti from TiCl4, right? Ti, mass of Ti from TiCl4, yes. So I am going to put the MR or the two answers from the balanced chemical equation. From this equation, the mass of Ti is equal to 48 plus Cl are equal to 4. 35.5 into 4 plus 48. The answer is 190. So according to the balanced chemical equation, you can say the from equation 190 gram of TiCl4 is going to yield titanium that is equal to 48. Is going to yield 48. If we are using 1 gram of TiCl4, it will be 48 over 190. And at the moment we are using 1000 gram. How much titanium should be made? How much titanium should be made? I mean, according to the calculation, how much titanium should be there if the 100% procedure is going to be the efficient? 48 over 190 multiplied by 1000. 48 over 190 multiplied by 1000. And here is the answer that is equal to 252.63. This is the maximum mass of titanium that can be made from this given data. Once again, as you know, here is the percentage yield indication. So I am going to write the percentage yield formula. Percentage yield is equal to expected yield, experimental yield and calculated yield multiplied by 100. I am trying to solve all the question of stoichiometry. Those are having percentage indications with this formula. I mean, simply use this formula and ultimately you would be able to find the answer of all questions. Percentage yield that is equal to 90%. According to my calculation, what the maximum mass we can make, that is 252.63 into 100. And let's suppose the experimental yield is equal to X. Indirectly, this examiner is asking the experimental yield. How much titanium actually that is going to be formed is this one. Once again, what is equal to x? X is equal to 90 into 252.63 and divided by 100. Please let me know what is the answer. G, please let me know. What is the answer of this expression? Multiply by 90 divided by 100, that is equal to 227.4. 227.4, and I think it's a correct option. Once again, it was the 3-mark question. The next one is, W is the compound containing carbon, hydrogen and oxygen. The percentage of the carbon is given, hydrogen is given, and you can find the percentage of oxygen. I mean, what is the percentage of oxygen? That will be equal to 100 minus percentage of carbon 57.1 plus percentage of hydrogen, that is equal to 4.8, and so on. So 57.1 plus 4.8, that is equal to this one, and I am going to minus it from 100. The answer is 38.1. 38.1 is the percentage of oxygen. Now the simplest mechanism is over here to find the answer of empirical formula. Carbon, hydrogen, oxygen. 57.1 percentage, 4.8 percentage, 38.1 percentage. Now divided by 12, divided by ARs, divided by 1, it's AR of hydrogen, divided by 16, that is AR of oxygen. So in this case, the answer is 2.38 almost. Here is 4.8, and what should be the answer in this case? 57.1 divided by 12, and the answer is 4.75. The lowest answer is 2.38, so I am going to divide 2.38 to all these species. I mean 2.38 divided by hydrogen for hydrogen, and carbons divided by again 2.38, and so on. It will be equal to 1. And what about the hydrogen? 4.8 divided by 2.38, that is equal to 2.0, I mean it's 2. And similarly 4.75 divided by 2.38, and it's equal to 1.99, again it's equal to 2. So empirical formula, as far as my calculations are concerned, it's C2H2O. C2H2O, and you know it's a 3-mark question. That is done, right? Okay. Now the next one is a 0.194 gram sample of W reacts completely with 18.5 centimeter cube of 0.250 mole per dm cube KOH. Once again, as I told you, whenever you see this one, the volume and the mole per dm cube, it means that you can find the number of moles. You can find the number of moles, and so on. I'm going to find the number of mole of KOH first of all. And first of all, mole, then unitary method, yes. Moles, 18.5 into 0.25 divided by 1000. Immediately you should find the number of moles without thinking the further step. 18.5 multiply by 0.25, yes, and divide by 1000. Divide by 1000, and the answer is 4.625 into 10 raised to power minus 3. Okay. A 0.19 gram sample of W react completely with this KOH. 1 mole of W react with 3 mole of KOH. This information is given. Instead of the chemical equation, you are given the information that 1 mole of W is equal to 3 mole of KOH. That's quite simple. I mean, question is solved. I mean, 3 mole of KOH is equal to 1 W. We are going to find the W, so I am going to write W on the right hand side and KOH on the left hand side. 3 mole of KOH is equal to 1 mole of W, and at the moment we are using this 1 mole, and 4.625 into 10 raised to power minus 3 will be equal to what? It will be equal to 1 by 3 into 4.625 into 10 raised to power minus 3. It will be the mole of W. Mole of W, right? Divided by 3, you can say the whole answer. And its answer is 1.54 into 10 raised to power minus 3 moles of W. Moles of W, right? So he is asking the relative formula mass. So I am having the mass. Now I have calculated the mole. So we can find the MR. It's sort of MR, you can say. It is also an AR or MR. Now I'm going to write mole is equal to mass over MR or AR. In this case, the mole is equal to 1.54 into 10 raised to power minus 3, and we are having the mass that is equal to 0.194, and we are supposed to calculate its formula mass, I mean MR. So MR will be equal to what? MR will be equal to, I'm going to cross multiply, and that is equal to 0.194 divided by 1.54 into 10 raised to power minus 3. Alright, so 0.194 divided by answer, and as far as my answer is concerned, it is equal to 12586.5.8, or you can say 126 gram is the formula mass. So he is asking to find to deduce the molecular formula of the W. You know, its empirical formula is this one, and its mass is relative mass is over here, or MR is over here. So you can find the relative molecular mass, relative molecular formula. First of all, I'm going to calculate the mass from this formula. This is empirical formula mass. Empirical formula mass. If I'm having the correct answer, then 2 into 12 plus 2 plus 16. What is the answer? 24 plus 2 plus 16. The answer is 42. Answer is 42. In this case, I'm going to find N. N is equal to MR over empirical formula mass. MR over empirical formula mass. MR is equal to 126 almost, and the empirical formula mass is equal to 42. 42, and I mean 126 divided by 42, it's equal to 3, correct? N is equal to 3. So it's quite easy now. I mean, the easiest one to find the molecular formula. How to find it? First of all, I'm going to write the empirical formula, C2H2O multiply by 3, and this 3 will be multiplied in this subscript. It will be equal to C6H6O3, and its MR will definitely be equal to 126. So that was a good question for 4 marks as far as my opinion is concerned. The next one is here are the two compounds. Both are the organic compound. One is cyclobutanol and butanoic acid. Calculate the percentage by mass of carbon in cyclobutanol. You are supposed to find the percentage by mass. Percentage by mass. The formula is equal to mass of that element, that is the carbon, mass of carbon in this compound, total mass of carbon divided by total mass, or you can say the MR. So how many carbons are there? 1, 2, 3, 4 carbons are there. 4 into 12 is the mass of carbon in the compound. What is the total MR? I'm going to write its molecular formula first. C4, 1, 2, 3, 4, 5, 6, 7, 8, 8 hydrogens and 1 oxygen, if I am not wrong. 2, 2, 2, 6, yes, 8. 12 into 4 plus 8 for hydrogen and 16 for oxygen, right? 12 into 4, I mean 48, plus 8 plus 16, and the MR is 72. So 48 over 72 and multiply by 100 for percentage. For percentage, out of 100 mean percentage mean out of 100. I mean 72, if the total is 72, at that time 48 gram is the answer. What will be the answer if the total is 100? I mean, so 48 over 72 into 100. 48 divided by 72 into 100, and the answer is 66.66% is the answer. The next question. Acid U is a compound containing carbon, hydrogen and oxygen. A 6.3 gram sample of U contains 1.68 gram of carbon and 0.14 gram of hydrogen. Calculate empirical formula of U. Now this time he is not giving the percentage. Now he is letting us the masses of the different elements, those we are going to have. The total mass of the sample is equal to 6.3 gram of the total mass of the sample, keep in your mind, and the mass of carbon is equal to 1.68 and the mass of hydrogen is 0.14. What is the mass of oxygen? What is the mass of oxygen? The mass of oxygen will be equal to 6.3 minus 1.868 plus 0.14. This mass will be the mass of oxygen in this whole sample. So these all components are going to mix together to make a sample. The whole mass is because of carbon, hydrogen and oxygen. The mass of carbon is equal to 1.68. The mass of H is equal to 0.14. The remaining mass will be because of oxygen. So you can say that 1.68 and plus 0 plus 0.14 and 6.30 minus answer, that is equal to 4.48. 4.48. So the rest of the procedure is quite similar. I mean, the mass of the carbon is 1.68, mass of hydrogen is 0.14, mass of oxygen is equal to 4.48. Divided by its AR, it's equal to 12, its AR is equal to 1, its AR is equal to 16. So what is the answer of the carbon? These are the basically ratios. And 1.68 divided by 12, and the answer is 0.14 gram. It is again 0.14 gram, and the last one is 4.48 divided by 16, and the answer is 0.28. So the smallest value is 0.14 divided by 0.14 divided by 0.14, I mean the smallest one. It will be equal to 1, it will be equal to 1, and it will be equal to 2. So the answer is CHO2. It's the empirical formula of the compound U, who is having 6.3 total mass. Again, that is a similar question. A 0.086 gram of the sample of U is completely neutralized by 12.7 centimeter cube of 0.150 mole per dm cube KOH. Once again, I'm going to find the mole of KOH. And here is the information. Instead of equation, 1 mole of U is equal to 2 mole of KOH. And I am going to find the mass of U. So I am going to put U on the right hand side and KOH on the left hand side. From this information, we can write that 2 mole of KOH is equal to 1 mole of U. Now, how much moles we are using experimentally? That is equal to 12.7 into 10 raised to the power, not 10 raised to the power, sorry, into 0.15 divided by 1000. So what is the answer in this case? 12.7 multiplied by 0.15 and whole divided by 1000, and the answer is 1.9 into 10 to the power minus 3. 1.9 into 10 to the power minus 3. So 2 mole is equal to 1 mole. If I am using 1.9 into 10 to the power minus 3, then the answer of U will be equal to 9.525 into 10 to the power minus 4. So here is the mole of U, and you know you are having the mass of U. You can calculate its MR, right? And once again, I'm going to find the MR. MR is equal to, or the empirical formula mass, or the formula mass you can say, that is equal to, not empirical formula, sorry. MR mean molecular formula mass. Relative formula mass, or the, you can say, the molecular formula mass. That is equal to mass into moles, right? Mass over mole. So mass is equal to 0.086 divided by mole, that is 9.525 into 10 to the power minus 4. What is the answer of its MR? 0.086 divided by its answer, and the mole is equal to, the mass is equal to 90.28, and I mean almost 90. So relative formula mass, I mean MR is equal to 90.28 or the 90, and he is asking to find the molecular formula. Once again, I'm going to repeat the previous one step. In this case, first of all, I'm going to find the empirical formula mass. I mean 12 plus 1, 13 plus 32. 13 plus 32, the answer is 45. Its answer is 45, right? So N is equal to what? N is equal to MR over empirical formula mass. MR is equal to 90. EFM is equal to 45. Answer is equal to 2. So the initial formula was CHO2, and I am going to multiply by 2. The finally answer that you will report over here, that will be C2H2O4, and so on and so on. The next one question is, ammonium carbonate is a white solid which decomposes when heated. Ammonium carbonate goes to ammonia plus CO2 plus H2O. A small sample of ammonium carbonate is heated in test tube. Describe how you will know when all ammonium carbonate has decomposed. So it's, I mean, saying, it's asking the sort of observations. This is a white solid. I mean, till there is no further appearance of the white solid, of the presence of the white solid is over here. When the all white solid disappear, it means that your reaction is completely finished, or it's complete and it is completely decomposed. The next one is, calculate the total volume of the ammonia and the carbon dioxide measured at room temperature and pressure formed when 4.8 gram of ammonium carbonate is completely decomposed. Once again, the equation is given. I am using unitary method or unitary rule. Put equal over here. What is to be found? The total volume of ammonia and CO2. Volume of NH3 plus CO2. What is given? Given is ammonium carbonate. I am given NH4 twice CO3 is given, and this we are supposed to find. From the balanced chemical equation, what is the mass of ammonium carbonate? What is the mass? From this equation, here we are grams of ammonium carbonate. The given species is in grams, in unit of grams, so I am going to put grams from the balanced chemical equation. What is the answer of grams from this equation? Ammonium carbonate, I am going to write it over here, N2H8CO3, right? So 2 multiplied by 14 plus 8 for hydrogen plus 12 for carbon plus 3 into 16 and the whole MR is equal to 96. So when 96 gram of ammonium carbonate is heated completely or decomposed completely, then at that time, how many moles of collective moles, overall mole of these two species are formed? 2 plus 1. So I'm writing moles over here. First of all, you can also put volume as well. It's no problem. But I am going to make a proper, calculation. So 3 moles of these both gases are going to form. When you are going to use 1 gram, it will be equal to 3 over 96. And at the spot, finally we are using 4.8 gram, and I'm going to multiply by 4.8. So 3 multiplied by 4.8 and divided by 96. The answer is 0.15. 0.15 moles of all these gases. And he is asking the volume at room temperature. You know, 1 mole is equal to 24 dm cube. And we are having 0.15 moles. Simply 24 into 0.15. That is the total volume. That is the total volume, that is equal to 3.6 dm cube. I think it is very much necessary to mention the units. If you're finding the answer in centimeter cube, yes, you can do it, right? And at that time, I think it will be 3600. So it is, it's wise to mention the units as well. The next one. Equation for the decomposition of hydrogen peroxide is shown over here. A sample containing 1 mole of hydrogen peroxide is completely decomposed. This sample releases 98 kilojoules of heat energy. Calculate the heat energy released when 680 gram of hydrogen peroxide is completely burned. Now in this equation you are having the information. 1 mole of hydrogen peroxide is completely burned. This sample is going to release this energy. So this is the basic data, basic given data. 1 mole of H2O2 is equal to 98 kilojoules energy. At the spot we are using 680 gram. So what is the mole of H2O2 from 680? 680 over its MR. What is its MR? Simply speaking, what is its MR? H2O2. H2O2, 2 plus 32, 34. So 34. 680 over 34. 680 divided by 34. And the answer is equal to 20. So at the moment, we are using 20 moles of H2O2. 1 mole is giving 98 kilojoules. The 20 mole of H2O2 will give 98 into 20. So answer is 1960. 1960 kilojoule is the answer in this case. Propyl ethanoate is prepared by the reaction between ethanoic acid and propanol. Calculate the maximum mass of the propyl ethanoate that can be made from 7.2 gram of ethanoic acid and excess propanol. Excess propanol means we have no concern with this one. Now, what maximum mass of propyl ethanoate? This is supposed to find, I am going to write CH3, COO, CH2, CH3 over here on the right hand side. And I am putting the given data, that is ethanoic acid, its formula is CH3CO2H on the left hand side. And according to the balanced chemical equation, I am putting these two values from the balanced chemical equation. The first method, the first step is, you will use these two answers from the balanced chemical equation. From balanced chemical equation. Right, what is its MR? I think its MR is equal to 60 if I am not wrong. Its formula is equal to C2H4O2. It is good to make the molecular formula first. C2, I mean 24 and plus 4 hydrogen plus 32, and yes, it is equal to 60. So 60 gram of, when 60 gram of that carbonic acid, ethanoic acid is going to react, what is the answer of this propyl ethanoate? Once again, I am going to find its simple molecular formula. 1, 2, 3, 4, 5, C5 are over here. 3 plus 2, 5, 3 plus 2, 5, 5 plus 5, 10, H10 and O2. So I am going to find its MR according to the balanced chemical equation. 5 into 12 and plus 10 for hydrogen plus 32 for oxygen, and its mass is equal to 102. So it means that it is clearly evident from the equation that when you are using 60 gram of ethanoic acid, the answer of this propyl ethanoate is equal to 102 gram. If I am using 1 gram, its answer will be 102 over 60. At the moment I am using 7.2 gram. At the moment we are using 7.2 gram. 7.2 gram will yield 102 over 60 into 7.2. So 102 into 7.2 and divided by 60. Divided by 60, and the answer is 12.24 gram is the appropriate answer, and so on. Right, exactly. Thank you, Kamar and Uzair. An oxide of the phosphorus contain 43.7% by mass of phosphorus. Show that empirical formula of this oxide is equal to P2O5. So you have to prove that the empirical formula that should be equal to P2O5. Once again, the mass of phosphorus is 43.7%. The mass of the phosphorus is 43.7%. What will be the mass of oxygen? It will be equal to 100 minus 43.7%. Right? It's divided by 31. It's divided by 16. Let's see what is the answer. 43.7 divided by 31, that is equal to 1.409. I think of 1.4 is the correct one, or you can say 1.41. What about this one? 100 minus 43.7, that is this one, divided by 16, and the answer is 3.51. So the smallest answer is 1.41. It will be divided on the both sides. In this case, its answer is equal to 1 and 3.51 divided by 1.41, and the answer is 2.5, I mean 2.4 or 2.5. Now we are not allowed to round it off. We are going to try to make them into the whole numbers. So I am going to multiply 2 to this, all these both integers, to change them into the whole numbers. So by multiplying 2, it will be 2 and it will be 5. So it is proved that P2 and O is having the 5 molar ratio, and so on. Calculate the mass of neon in 21 dm cube sample. Give your answer 2 significant figures. Mass, you are going to find the mass of neon in 24 dm cube. You know that we cannot find the mass directly from volume. So we can find the mass, I mean we have seen the formula of the mass, that is in mole 1. Mole is equal to mass over AR. So first of all, I am going to change this 21 dm cube into moles. You know that 24 dm cube of the gas is equal to 1 mole, and if we are using 21 dm cube gas, it will be 21 over 24 moles. 21 divided by 24 moles, that is equal to 0.875 mole. So this sample of neon is having 0.87 mole, and you know what is the AR of neon? You can check it from the data booklet. That is equal to 20.2 or 20, you can say. So mole is equal to 0.875 is equal to mass, that is we are going to find, and the AR is equal to 20.2 or simple 20. So the mass is equal to 0.875 into 20.2, and the answer is 17.675 or 67 and so on. So I mean, these are the typical questions 1 and so on. Aqueous ammonium nitrate decomposes when heated as shown. Ammonium nitrite, going to nitrogen, make nitrogen and H2O liquid. A 25 centimeter cube sample of 0.150 mole of NH4NO2 is heated. Once again, volume and concentration of the same species can be used. We can use these two answers to make the number of moles, and so on. Heated. Calculate the volume in dm cube of the nitrogen made at room temperature and pressure. First of all, what we can deduce from this data is this one, that is the moles of NH4NO2. That is equal to 25 into 0.150 divided by 1000. So that is equal to the mole of NH4NO2 used at present. 25 multiplied by 0.15 divided by 1000, and the answer is, if I am not wrong, 3.75 into 10 raised to power minus 3. It's the answer of moles. From the balanced chemical equation, you can see that 1 mole of this ammonium nitrate is yielding, is producing, is generating 1 mole of nitrogen. So according to equation, from the equation you can say that NH4NO2 is ratio with N2, that is 1:1. So what will be the mole of N2 formed? N2 moles will be equal to the similar one, 3.75 into 10 raised to power minus 3 moles. Now you know 1 mole is equal to 24 dm cube at room temperature and pressure. What will be the answer of dm cube if we are using 3.75 into 10 raised to power minus 3 moles? I mean 24 multiplied by this answer, that is 3.75 into 10 raised to power minus 3. And that is equal to 0.09. 0.09, if I am not wrong, is a mole, as a dm cube of the nitrogen that can be formed in this case. Almost all the other questions are having the similar fashion and so on. Now you are supposed to practice the more stoichiometry questions from winter 2017 to 2021. I think it will be sufficient to you for your this recent examination, and I think you will be very much clear after doing that exercise, and I think I have explained in a more better way to you, I hope. Thank you very much. That's all for today, and see you tomorrow inshallah. Allah Hafiz.